All right, we are about to do chapter 1, so go to page 1 in your geometry basics. It's the packet. I have a hyperlink in the calendar. It'll just say chapter 1 packet. So if you go to page 1 and you take notes with me, that would be perfect, and just do it on a separate piece of paper or a notebook. We're going to do the vocab to start with, so vocabulary is super important. These are geometry basics, some important vocab terms that you need to know. Point is a location with no size or shape. A point, everyone should know what a point is. Those will be labeled with letters. So capital letters, it could be A, it could be capital letter B, it doesn't matter, but it is a location with no size or shape. Now, a line is made up of points with no thickness or width. So a line has arrows at the end, okay? And a line will also have points on it. So if I have point A and point B, you only need 2 points to name the line. So the line here would be named line AB with this symbol above it. All right. The next one is a plane. A plane is a flat surface made up of points and extends indefinitely in all directions. So a plane, and I also want you to add this, a plane has 3 non-collinear points. So these points could be named A, B, C. And non-collinear, we'll get to that, means not on the same line. So you just need 3 points to name the plane. So this plane could be named A, B, C. Or a plane can also have a letter in one of the corners. So like you'll see something like this. And so the plane could also be named plane P because of that letter in the corner. Make sure you're also pausing the video so you can take down the notes and the actual definitions if I'm going too fast. So like I just said, collinear means points that lie on the same line. So here we have a line, and then we're going to have points on that same line. Those are collinear. If it's non-collinear, then those points won't be on the same line. It could be 2 different lines or somewhere where those points are not on the same line. Now, coplanar are points that lie on the same plane. So it might look like some type of flat surface with points on the same plane. If the points are non-coplanar, then you might have something that looks like this with points on the outside of the plane. They're not on the same plane. All right. Next, we have a line segment. Everyone should know what a line segment is, but if you do not, it is a measurable part of a line consisting of endpoints. So instead of arrows at the end, there are endpoints. Ooh, that was a bad line. With A or B or whatever the points are named, but the points are on the end instead of arrows. And we could name this line segment AB with this symbol instead of the arrows on the end above the letters. And so I would name this AB, or you could name it BA with the symbol above it. A segment bisector is a segment, line, or plane that intersects the segment at its midpoint. So if you have some type of segment here, and you can have a segment, line, or plane intersecting at the midpoint, right in the middle. So if I have this line here, it's intersecting right at the middle, which makes these 2 sides equal to each other. It goes straight through the middle. And then you would have points. So I can name this line L. I can name these points A, B, C in the middle. whatever, but is bisecting through that segment AB. A ray is a line that extends indefinitely. It just keeps going just in one direction. So you'll always have an endpoint on one side of the ray, and then the other side is an arrow because it just keeps going and going and going. So this point may be called A, and then you'll have some other point on there too, and you will always name it with the starting endpoint. So here it's A, B, and your symbol here will look like this with just one arrow on the end. All right, so go to page 2 now, and we're going to practice some practice problems, and then I'll have you try some on your own. So in question 1, it's saying 4 collinear points, 4 points that are on the same line. So there might be varied answers, but for example, we could say H, N, K, I are all on the same line. So we have H, N, K, I all on the same line. Next, it says a line that contains point M. Well, a line that contains point M is line P. Here is the name of the line in a lowercase letter, and we could say that line that contains that point M would be line P. A line that contains points H and K. H and K, we gotta find those. H, K, a line that contains both of those is line R here. See how it is named line R? And then another name for line Q. So if you don't want to use the lowercase q name, so here's Q, here's the line here, then you pick 2 points on that line. So here I could say it is line JK. Don't forget that symbol above it. You could say it's KJ. You could say it's LK. You could say it's LJ. It doesn't matter. Okay? And then the intersection where lines P and R intersect at, so you got to find P and you got to find R. Where do they intersect at? That's that point N there. So you need to say point N. Okay? Now here for number 2, it's using a plane with lines in it. So here it's use the diagram to the right to name the following, a line containing point F. So we have to find point F first. So here's point F. And a line that contains it, you could just say is line J. Because that line there is being defined with that lowercase letter right next to it. Another name for line K, again, you need to find 2 collinear points. So J, or K, is right here, so you need to find 2 points on that line. So you could name it, that line I think it's like almost a 3-dimensional perspective, so that's why it's dotted like that, but you can name this line, an example could be BC. Those are 2 points on that line, and make sure you have that arrow line symbol above it. A plane containing point A. What is a plane containing point A? So if we find point A right here, we can name this plane, again, by the letter in the corner. So here's the letter in the corner of the plane. So this would be named plane M. Okay? And then an example of 3 non-collinear points. Again, your answers may vary, but an example of this, 3 points that are not on the same line, I would just pick and choose 3 obvious ones. A, B, and F are clearly not on the same line. Okay? And then the intersection of plane M and line K. So the intersection of plane M and line K is at point E right there. At E, where the plane M and the line K intersect at. And now what I want you guys to do is I want you to try number 3, all of those, A through E, and 4 in a notebook, and then we're actually going to go over them in our next class meeting, and we'll go over the answers for those. And then I need you to check Google Classroom and look for the homework that is due for the practice problems. So I'll see you back.